We continue to compare popular building materials with foam concrete. We have already compared foam concrete with polystyrene and polystyrene concrete for a flat roof. Links to these videos can be found in the corner and description below the video. The next material is the main and most interesting competitor of foam concrete, mineral wool. The most interesting because the competition is not limited to the use of materials in the horizontal plane. Today, we will compare foam concrete and mineral wool for 3 insulation options: a flat roof, of course, a cold attic, and frame structures, including light steel frame constructions LGSF. And let's start with flat roofs. Mineral wool is laid in 2 layers. The lower layer is less dense for maximum thermal insulation. The upper layer is of higher density to protect the insulation from mechanical damage. And all this should be covered with waterproofing as quickly as possible because, as we all know, mineral wool loses its thermal insulation properties when wet and does not restore them when dry. And this roof cannot be used because it can barely withstand the load of walking. However, an additional layer of protective material, semi-dry screed, high-dense foam concrete, etc., laid on the waterproofing can solve this problem. There is no such problem with foam concrete. It is also laid in 2 layers, insulating and protective, but its density allows even the installation of heavy equipment. Let's move on from technology to comparison. In terms of heat transfer resistance, mineral wool shows 1.5 times better results than foam concrete, which means less of it is needed. At the same time, the cost of materials is about the same, and sometimes foam concrete is even cheaper. However, there is a nuance. The slope cannot be made of mineral wool, so an additional layer is needed, for example, of a semi-dry screed, expanded clay, or other materials that require an additional layer of vapor barrier. Also, do not forget about the delivery of materials, the cost of laying services, and a huge number of consumables. These additional costs, coupled with the risk of mineral wool getting wet, make it very difficult to use for flat roof insulation. It's worth mentioning that mineral wool insulation requires protective clothing and accessories. But where mineral wool shows itself perfectly is in cold attics. It is laid between wooden beams that perform a load-bearing function. Because of this, a layer of high denser wool is not required. It is necessarily closed on both sides, from below with a layer of vapor barrier to avoid moisture from the room, and from above with waterproofing in case of roof leaks. Because when moisture gets in, mineral wool, as you know, loses its thermal insulation properties, and the entire insulation layer will need to be changed. A ladder should be arranged along the beams for walking. Foam concrete is poured between the beams in the same way and is covered from below with a vapor barrier, but it is not necessary to cover it with waterproofing from above, as well as to equip the ladder. It is not afraid of moisture, and the D200 density perfectly withstands human weight. As a result, mineral wool can provide better thermal insulation in the attic with the same layer thickness, usually the height of the beams, but it will cost more due to the additional costs we mentioned earlier. In addition, if moisture gets in, it can shrink and cracks will appear, which is a big risk. Foam concrete, on the other hand, fills absolutely all the cracks and voids when poured, and after hardening, it becomes solid. As a result, mineral wool is a very popular material for insulating cold attics due to its simplicity and convenience, but it has many disadvantages and has historically been accepted as the best insulation. Who hasn't torn off pieces of mineral wool as a child for fun near heating pipes and then pricked and scratched themselves? But foam concrete is already on its heels in this matter and will potentially take its place as the best insulation because it is a warm stone, not a polymer, and does not contain formaldehyde and other hazardous compounds as in mineral wool. And the most interesting thing is the insulation of frame structures and LGSF. Such structures can be insulated with both foam, concrete, and mineral wool. As in the example with cold attics, mineral wool will have better thermal insulation performance with the same insulation thickness. However, the feelings inside the building from these 2 materials will be completely different. The fact is that mineral wool is placed in the voids of the structure and can absorb only low sound frequencies. Because of these features, the building will appear light and mid, and high-frequency sounds will easily enter from the outside and pass between rooms. In addition to filling absolutely all the voids, foam concrete increases the weight of the structure and creates the feeling that the building is made of stone. In addition, it is possible to lay all communications inside the walls before pouring, which saves significant costs in the future. It should be noted that foam concrete has certain limitations when filling vertical planes, such as the walls of frame structures. Firstly, since it is a liquid and contains air bubbles, the hydraulic pressure does not allow pouring more than half a meter at a time. Although in the footage you see, we poured 1.5 meters of D600 at a time, and everything was fine. Secondly, the formwork must be strong and airtight. As you can see, the competition between foam concrete and mineral wool is very tight in our examples. We deliberately did not consider facade insulation, because foam concrete does not stand up to competition. We also did not consider fire safety, because both materials are non-combustible. But from the examples we have considered, it becomes obvious that mineral wool is more convenient for self-assembly and more popular, while foam concrete in many cases proves to be better and cheaper, although it requires special equipment and specialists. Can you make foam concrete yourself, and what do you need besides equipment? The main problem with foam concrete is the quality of the foam. It is a key component for the creation of foam concrete. If the foam is unstable, the bubbles collapse and the material settles. And this is what created the myth of the unreliability of foam concrete. However, there is a solution. Our Livoton foaming agent creates a stable, finely dispersed foam that does not settle or delaminate. Thanks to this, the foam concrete remains strong, warm, and durable. We have been producing our foaming agent in Ukraine and exporting it worldwide for over 10 years. Thanks to it, thousands of cubic meters of high-quality foam concrete were produced in Ukraine in 2024. But how exactly does our foaming agent work? Thanks to a special formula, it forms a stable foam that does not settle for several hours. This allows the cement mortar to completely harden without losing its structure. That is why our foaming agent is an ideal solution for the production of high-quality foam concrete. In addition, Livoton offers comprehensive solutions for manufacturers, consultations, equipment supplies, personnel training, and support at all stages of production. We are confident that with the right approach to foam concrete production, this material can become one of the most popular in construction. And we will be happy to answer your questions and provide advice. So please contact us. Contacts are on the screen and in the description below the video.